And that brings us then to problem 5b8. That's a bit of a hassle. We have two sleds. You are sitting in one sled and your mass plus the sled is 90 kilograms. And you have a block here which is 10 kilograms. It's on a frictionless surface, it's on ice. And here is your friend, and your friend plus her sled or his sled has a mass m2 is 70 kilograms. You slide this block to your friend. Your friend catches it and your friend slides it back to you and you catch it. And the question now is, when this is all over, this exchange of this block, when this is all over, the question is, what is the velocity of each one of the two sleds? You're being told that every time that you move the block away from you, that happens twice, you first move it away from you and then of course your friend moves it away from her or from him, that then the relative velocity between the sled and the block is 2 meters per second. All right, well, this comes into various steps. Let's first take step 1. We have this situation, and a little later, when this block has moved, we have here the mass of 90, which moves backwards, and I will give that a notation V90. You may not like that. And here I have the block, which goes in this direction, V10. Forget this one. We know that the relative velocity between the two is 2 meters per second. Between the two, not relative to the ice, but this relative to the sled is 2. I will introduce the unit vector in the x direction, and I call that x roof, and I know that Professor Guth is not doing that too often. What this means then is that V10 minus V90 equals plus 2x. That is the information that the relative velocity equals 2. Now I'm going to do something that you may not like. I know that the velocity of V90 is in this direction. That's a given. That will not change. Therefore, I'm going to leave the bar off and already substitute in here a minus sign. So that the number that I will find later is the speed for V90, but the direction is non-negotiable, must be in this direction. And V10, I know is in this direction, so I will give that a plus sign, and I know whatever sign I find later for V10, it will be in this direction. So that then becomes V10 plus V90, because minus times minus is plus, equals plus 2. And this is my equation 1. So I got rid of my vectorial bars, but I keep this in mind. Now, the momentum here is 0, so the momentum here must also be 0. So if I write down the conservation of momentum, I have 0 momentum, and that equals 90 times V90 plus 10 times V10. This is the momentum I have before, and this is the momentum I have after. It's in vector notation. I play the same game that I'm going to play with the minus signs, and so I can change this to minus 90 times V90, no longer bars, plus 10 times V10 equals 0, and I call this my equation 2. Well, I have now two equations with two unknowns, and what do I find? I find when I solve it that V10 equals 1.8. It better be positive. If it doesn't come out positive, I would have made a mistake, because all the numbers must be positive. Because that's the numbers that I've put in are speeds. And V90 is also positive, plus 0.2, but we already assigned it to go in this direction. And you see that the difference is 2 meters per second. This 1.8, this 0.2, the difference is 2 meters per second. It better be 2 meters per second because I put that in my recipe. Very well, so now I have a situation that I have to go to phase 2. I have now here this object, 10, moving towards your friend with a velocity of 1.8. And here is your friend eagerly waiting, mass 70, and it has no speed. But a little later, when your friend has caught this block, here is the 10, and here is the 70, and both of you will go in this direction, and let's call it just V2. I have problems with assigning all these nomenclatures. I hope you forgive me for that. I simply call this V2 now. This is the velocity in this direction of the block and your friend after the catch is made. Well, no one is shoving anything now, so all I have to take into account in this situation and nothing else is the conservation of momentum. Before the hit, the momentum I have is plus 10 times 1.8, which is 18. The momentum is only in here because this stands still. Afterwards, I have 80 times V2, and so it follows immediately that V2 equals 18 divided by 80, which is 0.225 meters per second in this direction. So I know now after the impact that the two go together with this speed. Now we come to phase number 3. And what is happening now, that this block with the 70 are moving with 0.225, but a little later 10 will be moving in this direction, and let me call that again V10, and the block, excuse me, the sled with your friend is moving in this direction. Let's call that now V70. And you'll have to apply now, which is not so difficult, only the conservation of momentum on this system. And I'd like you to do that. And then of course you have to go to phase 4, because now here you are with your 90 and you're going back. I believe it was 0.2 meters per second. And so now when this one hits you, then of course you'll have to again use the conservation of momentum. I mentioned here that all you have to do is use the conservation of momentum. That's not true. You also have to take into account that this velocity and this velocity have a difference of 2. So I misled you. To go from here to here, you must take into account conservation of momentum plus the fact that the difference in velocity is 2. When this object in phase 4 hits this object, then all you have to take into account is the conservation of momentum, because no one is sliding the object anymore. Well, it's a lot of work, and I leave you with that. I want you to appreciate, though, that none of these collisions, if you think of them as collisions, when you slide something away from you, that is some kind of a collision. When you absorb it, that is some kind of a collision. That none of these collisions are elastic. Kinetic energy is not conserved. You can easily see it. If you catch the block, then the two velocities after you catch it are the same. You're stuck. It's like the marble stuck to the putty. Well, then there's always an inelastic collision. And where does that energy go? Kinetic energy is destroyed to some degree. Well, it goes into heat. Maybe into a little bit into sound. Maybe it goes into breaking the block in pieces. It has to go somewhere, but not in kinetic energy.